Recording in progress.
Okay, good afternoon, everyone. Today, I teach another skill, which is setting up cloud, Google Cloud, and Hadoop ecosystem on top of that. This is one of the skill set that might help for your resume. Do you guys know Shashank Gupta? So he's one of your alumni who just hired in BCG Group. It's one of the best consulting groups. So his first job after his graduation was working in a startup. They applied? I think he applied one and got 120K of grant from Google Cloud for doing like Hadoop Spark computations over the cloud. So this is one of the skill set that could be useful later on for you guys. But again, if you are individual project, you don't have to. If you're a group project on top of DataBricks, this is another platform that you can utilize for your final project. So because you should have, you should do your project in two different platforms. Okay, having said that, go to cloud.google.com and get started for free. It might be a little different for you. It might be the link for the starting the Google Cloud a little different. But basically, just ask your Gmail, your country, and it might also ask your credit card information, but give you $300 free credit for doing this task, which is more than enough for learning. So I wait like about 5 minutes for you guys. Just go to cloud.google.com and just make an account and just put your information and be ready for today's experiment. So my username used to be Auburn, so it's the name of the city. But for you, welcome your username. Even later, if you want to be entrepreneur, and you might do some, you might have some ideas in data mining, big data. Google Cloud is one of the ways. Usually startups lacks money, so you can get at least one of your previous friends who graduated in 2021. I guess, yeah. He got $120,000 for his startup. So I think if one of you did it before, so probably you can do it. But just keep in mind, Google is a for-profit company, so they give you a contract, but they want to get a share of your profit later on. So at the beginning, they give you a grant, but also just read all of the documentation, everything from the contract to see if it's satisfying for you or not. But again, usually at the beginning, these kind of grants are very helpful. So do you think, I think I haven't talked about Google Cloud yet because I'm waiting for you guys to register, but do you think, is it like infrastructure as a service, platform as a service, or it's software as a service? So platform? So why do you think it's a platform as a service? Uh-huh. Yeah, actually, at this point, almost all of your answers could be correct because we haven't talked about it yet. I just wanted to have some general idea from you guys. What do you think? So, but let's just go dig more into it. So you guys might have different ideas, or maybe you stay with your current ideas. Is there anyone here who reached to this page? Something similar? You already reached? Okay. And go to projects. So let me just open mine. What happened? So let me just close it. So here you might have no project here. So if it's the case, just click new project and just put any arbitrary name that you want. And you get to this page. So for me, it said my project new because it's my own name, but you might have different project name. Also, you know, the Hadoop cluster that we are going to work with is under Cloud DataBricks API. So you need to make it available. So how to do, go to, click on DataBricks. So I already activated, so you don't see anything, but if you see such a thing, enable, just click on enable. So if you click on enable, later on you have access to tool set for creating your Hadoop ecosystem. If you don't see, so here, you see these 3 lines, click here. There is so many icons there. Press Ctrl F. So when you press Ctrl F, you can search for DataBricks, and it should be something like this. Then click on clusters. And if you click, it would ask you to enable DataBricks API. Just click on it, and it might take up to 5 minutes to be fully activated. Even it might tell you some information that is activated, but unfortunately, what I have seen last few days, sometimes it says it's enabled, but it's not fully enabled. So then I wait a little bit here for everyone to have that API to fully activated. In case following steps, you see you cannot reproduce my steps, it might be it's not fully activated yet. So no worries if your commands and the results might be a little different from me. So let's wait a little bit here. So for your friends who just came a little late to the class, so if you have entrepreneurial ideas on big data and cloud computing, Google Cloud is a good platform for you guys. So you can have your own startup and apply for a grant from Google. And as I said earlier, one of your previous alumni got 120K for a startup. So if somebody did before, probably you can, but just keep in mind, Google would get a good share of your a startup profit later on. So just make your own judgment if you want to use this service or not. But at least when you do interview and they will ask about your skill set, this is actually a cool one. You can say, I can work with the Google Cloud, I can apply grant for your company, and I can do big data computing, Hadoop Spark over Hadoop Google Cloud. And I think do your own research, because this course is not for entrepreneurship. So just Google how to apply grant for Google Cloud. And just do your own research. So this is a good skill set that you can impress people who interview you guys. So you can, if you say such a thing, it's usually a very complicated one. Let's just wait 1 or 2 minutes, because I know even it might in your browser, on your browser, it might say that it's enabled, but it may or may not completely activated. So let's go to next steps. Hopefully your DataBricks API is fully activated. So again, click on navigation menu, which is like 3 bars on the top left, and search for DataBricks. So just do Ctrl F, DataBricks. Click, and then click on clusters. You might get to this page, or if it's not fully activated, if your data, it might ask you to enable, but you already enable it. So no worries if you see some warning that you haven't enabled it yet. So if it's enabled, I mean, the remaining step is not that much complicated. Just click on create cluster and select cluster on compute engine, then press create. Here, just leave everything as default. You don't have to change it, but I show you some sections. So there's so many physical clusters of Google around the country. So for example, US Central, South America, Europe, Asia. So if you're in Asia right now, maybe working with Asian clusters is better. And also you can pick your time zone, your zone on each specific region. Here, I'm working with one master, 2 workers. If you might remember earlier session, I talked about master node and slave nodes. So the master node takes care of your work and distribute on the slave nodes, and the slave nodes do the calculations. So I picked the first one. Second one is the simplest one, so just one master node. And the third one is for having much more reliability in case even your master nodes got broken, you have extra master node that take care of your work distribution. Policy just leave as none. So you can here change your operating system. Here is Debian, but you can change it. So if you ever work with Debian, Ubuntu, or I think there's CMOS, I think is the other version. So in case sometimes the different flavors of Linux have different commands. So if you are okay with Debian, just leave as it is. Also, you can pick other services. So usually, at least I pick Jupyter and Zookeeper. So if you recall earlier sessions, Zookeeper that just take care of Yarn and HDFS. So sometimes you might have an extra level of control on your HCFS system, and Yarn, maybe you can work with a Zookeeper too. I haven't taught it, but these are so many other technologies that we haven't time for. HBase is one of the most common ones. Zeppelins are also among Hive, Zeppelin, the common Hadoop ecosystem technologies. You can change the configuration. For example, this size, like 500 gigabytes, SSD formats. So with this thing, you can do some customization, but usually I just pick Zookeeper and Jupyter Notebook. So I don't need other settings, and then press create. So when you press create, it might take up to like 3 to 5 minutes to have your cluster ready. So the service that Google Cloud provided here for Hadoop is something between not completely platform as a service, not completely infrastructure. It's something between them. You have some control on your infrastructure, but also some control on your platform. But I think if you say infrastructure, sounds better because even you have control on your hardware, so you can pick how many servers, how many hard drive, RAM, those kind of, or even operating system. This is a shared service, and again, I just recall some of our previous sessions when we have working with the shared service. It depends on how many people requested from the region that you requested. If there is so many jobs or requests only sent to that center, it might take much more time to get your cluster ready. Some companies might reach Google Cloud and get their own privileged service, so they don't wait for this processes. So, but here, since we are using a shared service, even you might get a region that takes 10 minutes to have your cluster ready. I have my second cluster ready. So I use US Central. So is there anyone here who has his or her cluster ready? You're still waiting for provisioning. In case you have a question, you can ask me, but in case it hasn't ready yet, it's not your fault. So might be either your API hasn't ready yet, or the center that you picked for your cluster hasn't have enough free clusters to dedicate to yours. I wait a little bit here for you guys to catch up, or you guys have questions you can ask. Then I just go for the next part. Well, let's just click on one of the clusters. It shows how many memories engage each node, your yarn, CPU utilization, network bytes, HDFS. So almost everything is empty because you haven't done anything yet. So similar to PuTTY in Amazon AWS, you can have something similar here. So you access to Linux environment and you can do some commands. So for being able to do the commands, click on VM instances. And lower right, you see SSH. If you click on it, new page would pop up. This is just a Debian Linux command prompt. So with earlier on, we just picked Debian as a default operating system. So your commands here should be Debian friendly. So let's just do PySpark. So PySpark is already installed in comparison with AWS. You don't have to install Spark by yourself. That's the traditional command for checking programming software, programming or coding. So it's just typing hello world. So I do print, comma, hello world. I stay with the tradition. So similar to Amazon AWS, you can also set up Jupyter Notebook. You can basically talk with the Hadoop ecosystem, send some files. So we do some of the practices. So today I'm going to teach another topic too. And since it's not for everyone, I teach you the main thing about Google Cloud. In case you are interested, you can also Google how to connect Jupyter Notebook to Google Cloud. It's very easy to. So let's do some Hadoop commands here. So I put the commands on the slide. So for example, here, HCFSDFS just means I'm going to run a Hadoop command. -ls means list or listing all the files inside the user folder. So let me Control C here, copy. I came here, I go here, Control V, enter. So these are all folders within my Hadoop ecosystem. As you see, I have Peak, I have Spark, Yarn, Zookeeper, HCFS, DataBricks. So these are some of the folders and files within my user folder. Questions so far? Error message in the syntax. Okay, let me see your computer. So your life is easy. You don't have to set up Hadoop and Spark. For your final project, you can just do as it is. So also, this is one step for uploading your files into a Hadoop ecosystem. First, you need to create a bucket, then upload your file into the Google bucket, and from Google bucket, you send them into Hadoop ecosystem. So me tell you. Again, click on navigation menu. So with that 3 bars. Storage is one of the services. There's too many services. I usually just search for name. So it's storage. So pick cloud storage and click on browser. So I already have, you might have at least one bucket related to your project. You can stay with that, but also you can make your own bucket. So click on create bucket. And here, your bucket should be a unique name. It's like email address. So if somebody already picked your bucket name, you cannot do that. So just click on it. Sorry, just put a unique bucket name, then press create. It might take a little bit, and then you have a bucket name there. So a bucket with your own name. Also, please go to the week 13 materials. You don't have to upload these files. In case I might give you later another video, either synchronous or asynchronous or in the class, about how to work with that bucket. But if you look at the materials, there is a folder with the name of data to GC, and I put 1, 2, 3, 4, 5, 6, 7. You can upload this. You can just download and upload later, but these are just arbitrary files. Yes. Question? It's not related to it. Just listen. Don't do anything. Yes, yes. So that the one that you click is your own command prompt. This is the command prompt for the cluster. Just the PySpark here. Now it will come. After you can just type quit parentheses and go outside the place, so you get back to the command prompt. Then do PySpark on print something. Yeah, you can do print parentheses. So here, Clark bucket is my bucket name that I picked. So I already have files in it. If you want to upload new files into your bucket, there is a button there with upload files. Just click upload files and select the files that you want to bring into your bucket. You can select all of them, press open, and all of them would come into your Google Cloud bucket. Yeah. It's one of these, but you control it. From now create, so you should pick a unique name. Okay, so the next step is just having this bucket connected to your Unix over the cloud. Put all the required commands here. So just go to the WIC14 txt file and just copy paste the commands that is I put in that txt file. So you will be able to connect the bucket to your Linux of the cloud. So let me show it to you guys. So I open WIC14 txt file. I put so many other commands, so we don't have time for today. But the first part, installing GSC Fuse, just copy paste one by one. So select everything, Ctrl C. Here, Ctrl V, and just press enter, and you just install one by one. So here, for connecting your bucket to your Google Cloud, you need to copy paste these 5 commands. First one, be sure to select all the line completely. If you don't select completely, you might get some errors. Okay, I messed up with my, let me just open it again. Yeah? You have a question? Okay. Give me 1 minute. So, no, you should have all of them. Go up, no? It's fine. And do it one by one, just one line first and second. So if you think it's messed up, just close this bit. That should be if you can find it. go to just do those lines one by one. Just like sure. Then you should pick this web inside Facebook. Command. Okay, then I want to fuse that bucket to a folder name in my Google Cloud. So as you see, inside SSH, I'm making a new folder. GSC fuse, I'm fusing that bucket name to the folder name that I make. So for you, if you probably this part which I'm highlighting here, so let me just make it yellow. So for you, this part might be different because every bucket should be unique. So the yellow part is your own bucket name. So first you create any folder on your system with mkdir. So Ctrl+C. I already created. So, and I'm fusing this bucket to that folder. So cd look, after fusing that bucket name, the folder that I created over Linux, with cd command, I went inside the folder, and when I do ls, these are the files that was on Moodle. I downloaded and then uploaded in my bucket. So basically, now whatever you're doing with that bucket would be reflected to data folder in your Linux folder. Maybe here there's a typo, so I should say cd data folder without a space. So creating a folder using your bucket name, which is different to the folder you just created. And if you go inside, you can see all the files that you uploaded on your Google bucket. Okay, so there is an optional assignment, which I might give you later after this semester, or most likely in the last day, I give you the solution. So if you might remember in the local instance of Hadoop, I show you some commands how to send files from your local system into Hadoop. Similarly, just Google it. So you already have Hadoop installed here. You need to learn how to send your files from this data folder on your Linux into the folder on Hadoop. On top of that, if you want to use Google Cloud for your project, you need to learn how to connect Jupyter Notebook over Google Cloud to your own system. So on AWS, I show you something similar. So we had we installed Jupyter Notebook over AWS, and we connect based on some IP addresses to local instance, to your browser on your local system. You should do something similar here to be able to to use Google Cloud for your own final project. So 2 things left as an optional assignment, and I give you a bonus if you can do that actually. So even if you are in the individual project, this could be a bonus, so you don't have to. So just you do your own research, how to send files from Debian Linux to the Hadoop that is already installed there. Second, how to be able to use Jupyter Notebook that is installed on a Google Cloud on your browser. So because let's go to command prompt here. If I type Jupyter Notebook, it's on there, as you see, 127.81.24. But this 127 is local address on your Google Cloud. It's not your own system. 127.0.0.1, it just means localhost, but this is a localhost on Google. So you need to just do your own research, how to find some IPs that you can just put on your system and connect to that Jupyter node. So these are 2 optional assignments, which is not actually difficult. So if you recall what we did in first part, which is sending files from Debian Google Cloud to a Hadoop, is very similar to what we had from local system to Hadoop. The second part is very similar to what we did with AWS Cloud, which you connect Jupyter Notebook, your own browser, to Jupyter Notebook over Amazon AWS. But again, these are very good skills, very complicated one. If somebody can do it, I mean, it's not too many people who can do this stuff. It needs some learning. I don't say it's super difficult, but still complicated for master students. So I think if you learn these things, you are really in good shape in terms of your skills. So let me go over model. Here I'm adding a bonus assignment. And let's just have a due date by let's say May 4th. Questions? Okay, so if there is no question, please download a searcher streaming using Python data frames and upload it into your DataBricks account. So if you, okay, we already talked about how to uploading your files. Also, you need to have your cluster ready. So you will be able to run the commands that are available in this notebook. I think you can distribute that. Oh, no. Yeah, I think because people are waiting for the clusters to be available. So I think.
The school, our school, ask you to do a survey after you graduated from one university, and this will help to boost our rank in US news. So currently, if you are having job searching, you can just hold it on and stop, like, don't do the survey. We'll contact you later and ask you to do it. So now you just give us your contact information in case we can contact you. And once you secure the job offer, whatever where it is, in China, in Nepal, in Vietnam, offline, you complete the survey. Or if you have then after then find a job, yeah, you do the computer information. What time to no.
Yeah, US News has different measures for ranking. So your school ranking used to be 60 in the United States. Now it's just going down. One of the things that we found is nobody answered to the survey. So it could affect university ranking. Also, it might be good for you. I mean, you graduate from a better rank, university better rank. Why not?
Yes, we are near 100. If we do well in this year, we may enter the top 100.
It used to be near 50. I think it was 60 something. Now it's over 100. Tim, could you give me like a couple of copies? Just ask your friend. Yeah, 35% is really high. So it's one of the main factors. We lost so many rankings last 2 years. So let's talk about today's topic. Today, so one of the more complex topics is streaming, or I mean here PySpark streaming. So basically, in PySpark streaming, you either work with the messages that Kafka sent to you. So on the spot, you can analyze Kafka messages and basically maybe use for prediction if is it the important message or not. For doing text message streaming, you need to have some programming knowledge of Scala. This is very out of content for this class. So in case if we offer maybe a PhD program in that, maybe we talk about Kafka streaming and how to do analytics over that. But that one is not even that much common. The more common one is working with a stream of files. So you might have input from an sensor that send one basically batch of files and just dump it somewhere on your Hadoop ecosystem. So Spark can access to that stream of files that just keep coming to a folder and basically open up each one by one, let's say every 1 minute, every 1 second, or 1 hour, then process the file, put it somewhere else, and then just keep processing the stream of files that are saving on a folder. So for today, we do PySpark streaming, and our focus is on a stream of files that might come from a sensor. So it might be a little off topic because it's not even related to your project, but just let me skim through that notebook. So here we are working with a DataBricks folder. I put the location of folder here, DataBricks structure streaming /events. Here, although there is already 50 files there, so with ls, you can see the list of files in here. This is all from 0 to 50, so 49. So there's a 50 files here, but we work it as a stream of files because each file has I open it later on, so each file has a time set. So the way that we work it, so Spark check our hourly file dump and then process files one by one. So it just assume that files are coming, which are not coming. It's already 50 on a queue, but it just process one by one. So if the new files come into that folder, it also be able to process them again and again. So it would be an ongoing process. So no worries, let's just do one by one. So first I'm doing a list of all the files that are in the folder. And here, with head function, I can see what is inside my file-0.json. As you see, just have a timestamp. So the number that you see there, there is some Python function that you can convert it to regular data format. So this date format is in the computer format, but again, just Google it, find those functions. You might convert it and you see it might be related to May 7, 2021. So this date format is only, which has a long digit string, is a computer-friendly date format. Okay, here, first info input path has a folder that has all the files. And we also define a schema. We said that the first one is a timestamp, time as a timestamp. The second one is action, which is a string. So again, as you see here, each line is a Python dictionary with 2 keys of time and action. So time is a timestamp, action is just a string. It could be open or closed. So here, almost everything is open, but you also see closed ones here too. So and again, this is one of the files. There is 49 other files, which in each of them, you see such a lines. So it might be just a sensor information. So it might just come from a sensor that is that says a valve is open or closed. Okay, here I'm defining the schema, and also this spark.read. I'm reading all the files that are within that folder. And as you see, I'm just saying that Spark read this schema. I already defined the schema, and also the location of all the JSON files. With display, you can see a table that shows all the files that are read. So you just see the first 1,000 rows. So this is the summation of all the sensor information. So again, as you see, when we use display, since we already said this is a timestamp schema, you've seen your time in the human-friendly format. So for example, this one, 2016, 7/28. Questions so far? Okay, so far we just saw what we have in that folder, but now we want to tell PySpark that this is a stream of file. You might see something in the queue. So we already have 50 files in the queue, and we don't send anything anymore. But you just tell Spark, just pick the files based on 1 hour time window, and just process them accordingly. So Spark just pick the first files in terms of their order. Let's say it looks at here, and it seems maybe here, I'm not sure 7/28 is the first day, but it just starts from there. Let's say it's the first date that you have information. Then it just go from time 0 to time 1, 1 to 2 a.m., 2 to 3 a.m., just goes one by one. You already know that no new file would be added to that folder, but we don't tell it to Spark. Spark just think files just coming up. So here, I'm just saying that, okay, so this is here all the files is static input df. I'm just saying the group by based on action. Again, action is this column name. And time window is just 1 hour. I'm registering this SQL query. So later on, I can just refer to that and do some SQL-based commands on top of that. Also, I'm using the .cache method. .cache method is just saying that save this query on your memory, so later on you can access to a static count df quicker. From that SQL query, I can do multiple things. For example, I can look at sum of all of the counts and group by the action. So here, you probably, if you run now, let's just wait a little bit to be wrong. Again, these are static, just static counts. I haven't started streaming yet. So in a static count SQL query, I have information of all of my JSON files together. So it seems 50% of sensor data is closed, 50% open. Now I can basically make a query based on time, and then I order them based on time and action. So if you look at the plot information, it seems at the early on, there is more open than closed sensor data. So most of the sensor data saying that the sensor is open, but gradually when we go to the last part of our or later parts of our data set, it seems most of the sensor data is related to closed, or they say that sensor is closed than open. But if you look at previously, it seems in general, both of them are same. I mean, the sum total count of both of them are same. Okay, now we want to, so far we look at our data as a static pile of files. We sum them up, we made a SQL query, and we also sort them out based on, or group them by just based on action, and also based on action and time. As you see, my data starts from July 26, and the time is, I mean, let's say 3 a.m. and 9 a.m., 15 a.m., 21. It goes July 27 at up to 3 a.m., 9 a.m., 15, and just keep going until July 28th, 3 a.m. So this is all my data. But now, after that, I want to just start Spark streaming and just say Spark, just look at the files and just consider 1 hour by 1 hour. So here, instead of a static input, I'm using, or just read, I'm using read stream, the schema. I'm just saying that a time window is 1 hour, and all of my files is within input path, which I already defined. And I know it might be a little fuzzy for you. We don't teach Spark streaming here. We just want to have experiment. Spark streaming, as I say, is a little related to the, if we have another big data computing class, it should be your next class. But here we just want to show you some experiments. So no worries if these commands looks a little fuzzy. So the goal is not teaching you Spark streaming, just have some feeling of how it works. Anyway, in this one, I'm defining another query, so which read the streaming input and then group them by based on action folder, because we have one of the folder was action, and the one based on the time, and with the time window of 1 hour. And then I check if streaming count df is a streaming. The answer is true. So now define a streaming object over PySpark environment. Okay, so similar to SQL command, which we made a static query, which gave us information of all the files together. Now we do a streaming query. So look, now Spark streaming command, look at the files one by one. Just, I'm opening up the accounts here. Look at here. Files are coming into a Spark stream, because Spark stream just check one by one. Here, when I want, again, group them by based on time and action, each time, this time is like this. Look, then when I think, let me just wait a little bit. Now I have more data. I wait a little more, because still the information is coming into my system. If this time I make a SQL query and I group them based on action folder and also time, you might see much more information. So the Spark streaming is working here. So look, first I have limited data, so I don't have that much of a bar chart. When I wait a little bit, I have more bar chart. It just a stream of files coming to my system, and finally I have much more bar chart, because now most of the files are my system read most of the files right now. Even the total summation is still open, is more than closed, because it's still reading the files into my system. So do you guys recall SQL commands that I'm doing here? Have you had a SQL course before? Okay. So does this command make sense? Okay, hopefully, okay. Because if you don't remember this SQL command, the thing that I'm saying here is fuzzy. So basically, the overall goal is to see that it's such a thing. So you can make a streaming query and then read the files one by one. So as you see here, still files are coming up into my system. If you look at the block number 19, you see that there is a loading icon here. It just means that data is loading my into system, or basically my PySpark expecting new files coming. If you cancel it, that streaming query would stop. But as long as this streaming query is working, your system is expecting new files and just sum them up their information. Questions? Again, no worries if this part is fuzzy for you. So Spark streaming still is not the main topic here. It's the topic for a separate course. I just want you guys to have a feeling that how Spark streaming works. So it can either work with the Kafka text stream or work with the files stream. So you might have a folder somewhere that files coming up, and your PySpark just process them one by one. Okay, so if there is no question for today, that's fine. Again, the goal of this course was you guys first being able to your machine learning analytics parts over PySpark environment. Second, learning the concept of Hadoop and Spark and why you should do that, and getting familiar with some of the technologies. So you can do by now. You should be able to do some Hadoop commands, some pick command, some PySpark SQL commands, and also knowing some, having some familiarity. I think Pig you don't need to learn because it exactly looks like SQL. PySpark SQL might be a little different. Also, Kafka, and also I want you guys to have some familiarity with technology, like what does Kafka mean, how it works. So for messaging, or what does PySpark streaming do? So you can work with a stream of data comes from Kafka, or also you can just have a Hadoop folder somewhere that files would be dumped there gradually, so your system keep processing them. Okay, that's for today. Again, next week is your presentation week.